Hello and welcome to a new episode of Library of the Week. Today we will be talking about NumPy, a library used for numerical computation. Before I continue this video, this is part of a Medium article it's a series of articles that I write about Python libraries. Each week I try to make them, and each one of those articles comes with a video, so this is the one for the NumPy library. You can find the link to that article in the description of this video. NumPy is a very important library if you want to work with data and Python. In my personal case, it is a library that I don't use too much in my day-to-day work, although I try to use it more and more, and I think it is very important to learn it. Now, when I say that I don't use it a lot, this depends, right? Because actually NumPy arrays, which is the big concept that this library brings, the NumPy array, they are used to build the pandas data frames, and that is something I probably work with every day when I'm at work. So depending on how you want to see this is a library I use daily or now more and more. NumPy is a library that allows you to work with multi-dimensional arrays, and it is designed to make very efficient calculations. All the calculations that you can do with NumPy, you could do them with, let's say, Python lists. The big difference, very important, is that it's about 100 times faster when you do it with NumPy arrays. And this is why those NumPy arrays are used in pandas data frames, and also it is the base for example, for some machine learning libraries such as TensorFlow. It's used to build the tensors, so that it's out of scope of this video, but just know that this library is really very important. The reason why I don't use it personally too much at work is because, as is for a data analyst such as myself, I don't do that many numerical calculations on just numbers, right? Like I take data and I basically use pandas data frames most of the time. There is actually a whole bunch of reasons why the array is faster than lists and other structures. It is not in the scope of this video, but if you check the extra resources that I put in the article, you will find more explanation on that. If you are into scientific Python, then the NumPy array is something that will be very interesting for you. It really allows to do algebraic operations, and for some people it is supposed to be a good alternative to MATLAB. I say this like this because I really don't use MATLAB. I think I used it in university like over 10 years ago, but I have not really used MATLAB at a serious level ever. NumPy is a very well documented project, and it benefits from a very large community of users and developers. This project is actually linked to the PyData community, so you can find tons of resources in this webpage, or when you check for PyData events, there is information on YouTube, conferences, and so on. So this is very this is very good to know. And also this is a NumFocus sponsored project. We saw this in the Pandas episode. NumFocus is a non-profit that sponsors a lot of data projects. So Pandas, NumPy are some of them. There is also the Julia programming language and some other projects that are very big in the data community, and of course all this is open source and free. As of August the 28th of 2023, we are on version 1.25.2. In the last 30 days, the library has over 160 million downloads on PyPy and almost 5 million Conda downloads. The first release of NumPy is from December 2006, so you can see that this is a very old library for Python standards, and the latest release is of August of 2023, so very recent. It's a very well maintained project, and it also has 0 dependencies. On the GitHub side, it has 24,000 stars, a bit more, over 8,000 forks, 597 watches, and 1,515 contributors. The library has a source rank of 31 in libraries.io. Let's now see some examples of things we can do with NumPy. The first thing we can do obviously is creating a NumPy array, since everything in NumPy is about these NumPy arrays. To do that we have to import NumPy, and then we create our array with the np.array function. In fact, we have to import NumPy as np, and as you can see, the NumPy.array accepts a Python list as a parameter, so this list will be turned into a one-dimensional array. But since NumPy allows us to work with multi-dimensional arrays, this means we can also create a 2D array. To do this, we can pass a nested list like this. Make sure when you create a two-dimensional or a multi-dimensional array that the lists that you pass as arguments, the nested lists, need to be of the same dimension. So here you have to see this as a matrix with three lines, and 2 columns. And here I added this extra 7 to make the treatment fail, but this works, right? So we have 3 columns and 2 rows. We can also create some other matrices with different functions that the np array. For example, the np.zeros will create a matrix that is filled with zeros, and as parameters we pass a tuple, and this will be the dimensions of the array. So this will be a 2 times 3 array that will be filled with zeros. We have a very similar function called np.ones, and well, it's basically the same, just it fills with ones instead of with zeros, and this will be a 3 times 2 array. And then we can also create the identity matrix, so it will be easier when it's printed. Here we only need to pass one number as parameter, because the identity matrix needs to be actually a square, so it has to have the same dimension for columns and for rows. So it can be 3 by 3, it could be 4 by 4, but it cannot be 4 by 3, for example. So let's create this, and now let's print each of these matrices. So the 2D matrix that we filled with zeros here, as you can see, is totally filled with zeros. The 3D matrix with ones, this was a mistake, is here filled with ones, and the identity matrix has the ones in diagonal and everything else is filled with zeros. We can actually force the matrix to have a different type. So here you see that each 0 and each 1 has a dot after it. This is because they are float type numbers, but if we can use the d type parameter, and let's say we want it to be integer 8, and see here the ones array where we chose the d type, so d type stands for data type, to be of integer 8 is now integers and there is no dot. Now these matrices, we can do every matrix operation that you can imagine can be done with NumPy arrays. So for example, we can take this 2D array matrix and add 1. So this will add 1 to all the numbers in there, right? So 1, 2, 3 became 2, 3, 4, 4, 5, 6, 5, 6, 7. We could have also squared this. And so these are all the squares of this matrix here. So we can perform all these operations, and we can also operate between matrices. Matrices can actually be summed, and you can multiply matrices. This follows certain rules. I am not very much into algebra. I understand the basics, but it's not what I do in my day-to-day life, and I don't feel comfortable explaining all this. But let's say that we define two arrays, array A and array B, with the same dimensions. So these are one-dimensional arrays of 3 columns each. We can actually make the sum of array A plus array B. And in this case it works because they're basically the same dimension, right? So 1 plus 4 is 5, 2 plus 5 is 7, and 3 plus 6 is 9. And finally we can, well, finally, to finish with these easy examples, set of examples, we can also do some basic statistics with this. So there is a sum method that will return the sum of all the elements in the array. So array A has elements 1, 2, and 3. The sum of 3 plus 2 plus 1 is 6, right? And array B should be 4 plus 5 plus 6. This should be 15, and it is 15. The same, we can get the maximum value, which is 6. The minimum value for B should be 4, and so on. We have this basic set of functions. We are now going to see a more complex example of things we can do with NumPy. The goal here is just to show you what is possible, not to go very much into depth, but to make you want to use NumPy. By the way, the links, the extra links that I put in the Medium article also have some cool other projects that you can do with NumPy, especially linked to machine learning, so I highly suggest that you check them out too. Here what we're going to do is use NumPy to change the coloring of an image. So here I have the NumPy logo. As you can see, it has two different tones of blue, and we're going to turn it red using NumPy. We're going to need to use a library called Pillow as well, but don't worry too much. This is just to open and to save this image that I have here, and to save the image that we're going to generate. Actually, Pillow can do lots of things, but in this context, we're just gonna use it for that. All the magic, all the processing is going to be done with NumPy. So I import Pillow, so this library is called Pil. You can install it using pip install Pil. There is chances that you have it already installed. It's a very popular library, and it's used by a lot of other libraries for image processing. And what I do is I'm going to, well, in fact, I don't import all Pillow, I only import the image class, and I use image.open, and my image is called numpy.png. And now I have this object, this Pillow object, and I can convert it to a NumPy array using np.array, like I would with lists. And here I have it. So let's see image array. Let's see what it looks like. This array, here you see lots of zeros. Each of the inner arrays, the 0, 0, 0, 0, each one of these zeros here represent an integer value for RGBA. So R is red, G for green, B for blue, and A for alpha channel or transparency. In other words, this is the notation of a pixel as a NumPy array. The image, if you conceive it as a matrix, it's going to start from the top left corner and it's going to read towards the bottom right. And we have the first and the last pixels here. And one thing I didn't tell you, the white that you see around the image that belongs to the image is not actually white. In fact, it is 100% transparency, and the white that you see is the white of the background. This is why everything is set to 0. Another thing I want to show you, the shape of the array. So you see, this is a three-dimensional array. It has dimensions 864 times 1920. So this is how many pixels. So x64 times 1920, this is the image size, and then 4 is the size of each individual pixel, because each pixel has this 3-color information plus the transparency level, right? So that's one thing. And just to show you that it's not only filled with zeros, so this is image array, and we're going to take 500 and 500. This is just a random pixel. Sorry for that. So if I go to position 500 and 500, I have this pixel here. As you can see, red 77, 171 for green, 207 for blue, and 255, which is the maximum value in decimal numbering when we have integers of 8. This corresponds to a byte filled with ones, but if you don't know binary notation, don't mind too much. What matters here is that numbers can go from 0 to 255. And now that we have this matrix, we're going to create another matrix that will be a filter that we're going to apply. So let me show you the matrix that we're going to create. This matrix will be called red filter, and it's a NumPy array of 2 dimensions of 4 by 4. So see here you have a one-dimensional array with 4 elements and you have 4 rows, and the trick here will be to multiply this red filter and this image array. So it's going to be matrix multiplication. The concept of matrix multiplication is a bit difficult, but what matters is that each one of these inner arrays, like each vector here, is going to suffer a transformation. Here in the first row, I put 1 and then the rest is filled with 0. So this is going to transform, well, in fact it's not going to transform because it's going to do a multiplication by 1 to each of these first elements or first numbers, first integer, within each one of the NumPy arrays that are in this 864 times 1920 NumPy array. So you can check matrix multiplication because in fact, if I had put numbers here other than 0, this would have altered the final result. But yeah, if you're not familiar with the concept, I'd suggest you go to Wikipedia or to a math textbook or something and check for matrix multiplication. But this way we are keeping the red in all the NumPy arrays that are in the third dimension, if we wish, of this image array. Then we have green and blue. And here we fill each one of these arrays with zeros. And what this is going to do is that it's going to force each one of the next 2 elements in each one of these arrays to be multiplied by 0. So anything multiplied by 0 becomes 0. And so we're basically eliminating all the blue and all the green color in this NumPy array. And here with the alpha channel, we want to keep it because if I had put a 0 here, everything would have been transparent and then we would have like no image at all, right? So we want to keep the transparency just like in the original matrix, and this is why I keep the 1 here, and it's in the last position. So if I wanted to keep the green, I would have set the 1 here in second position and for the blue in the third position. So let's create this matrix, and now we're going to do the multiplication of the 2 matrices. To do that, we're going to create this in a new variable called filtered image array, and we use the np, so numpy.dot method, and this basically does the multiplication of image array by red filter, right? So the 2 matrices that we have created. This notation with the 3 dots is called an ellipsis, and it is basically a shortcut that represents multiple columns. So we're basically accessing each one of these arrays in the structure. So the multiplication will happen between each one of these arrays and this red filter array. And we make it as type integer 8, just like the original array. And we should be good here. Let's see how this filtered image array looks. It's all filled with zeros when we put this, well, the first arrays, just like in the original image. This is not surprising because all zeros, when you multiply, is going to be all zeros, and we're keeping basically the transparency. If I do the shape, it's the same shape as the original image array, which is what we were looking for. And if I take the 500, so this is a random picture I took before. We have here 77, and when we see the original one, it was 77 too, so the red has been kept intact. 0 and 0 then after that, so the 171 for the green and the 207 for the blue are now gone, And 255, this has been kept, right? This is the alpha channel, and this is what we wanted. And now we just have to save this image, and we're going to use pillow again for this. So we're creating an object called image array, and notice that pillow accepts NumPy arrays to create images. And now just to save the image, and this is pure pillow, we use the save method. Let's see how the modified logo looks. Boom, it's all red, and well, this is what we were looking for. So I hope that this more complex example has given you some ideas and it's made you want to learn how to use NumPy. That will be it for today. Thank you for watching this video. Like it if you liked it, subscribe and click on the notification bell. And until next time.